Fundamental quantities, there are three types of quantities. What are those? Fundamental quantities, derived quantities and supplementary quantities. Okay, fundamental quantities are what? From where, those are basic quantities from where everything is defined. Okay, like length, okay, then time and mass, and next what? 7 are there. Length I mentioned, temperature and ampere, current. Ampere spelling is what? ERE, correct na? H, correct na? No, that is radius. Wait, that is not SI unit. Say 3, 5, 2 more. Temperature done. Luminous intensity. And mole, right, to measure the number. These are the 7 fundamental quantities. Any other quantity you can derive from here. Okay, the 2 quantities are more there, radians and steradians. Okay, like one is angle theta, that you radian you measure. Okay, and steradian is solid angle. You will use in electrostatics. There I will tell what is, how to solve for solid angle. Okay, so these are the basic 7 fundamental quantities from where anything can be derived. Like let's say for example, if we talk about acceleration. Okay, acceleration is what? Velocity. Or you first let's talk about speed. Speed is what? Distance upon time. The distance is taken from here, time is taken from here. From these 7, whatever you can derive, you can derive. Okay, understood? These are fundamentals. Got the point? Okay. Next is unit conversion. Okay, unit conversion, let's say how I explain is that basically let's say there was another 2 different civilization you take. Okay, one civilization is measuring unit in meter. Like let's say they took this much of length. Okay, and they said that this is 1 meter, or they said this is 1 meter. They defined this is 1 meter. Now if something comes this much big, they say this is 2 meter. Okay, like they are measuring it. Okay, if someone says that give me 3 meter rope, they will give, right? They know, because they are in their civilization that is going in meter. Okay, when another civilization came, they are measuring in some other unit. They said feet. So this much is 1 feet. Okay, they define like this. So for them 2 feet is this much. If those civilization communicated for trading or something, right? I said I have 2 meter of this, right? Now that the problem is, what is 2 meter? First of all, what is meter? You tell me that. Okay, because of that, when you see the conversion of feet into meter, because those 2 civilizations are very different. Okay, when you will see the conversion, you will have 1 meter is equals to some 3.2 something like that. There will be 4 or 5 digits here. Okay, because they were not communicating with each other and separately. So when they measured, there was some difference, but already it has very expanded, right? So you can't just say that you neglect, you forget yourself and you use ourself, use our one, right? Like that you can't say. So that's why there was, both were working. Okay, now they said, okay, meter is this much. Okay, but let's say if I have to measure some small quantity, then I will not say every time 0.2 meter, 0.1 meter. Why would I say? Give me some number, right? So they said meter you divide in 100 equal parts, and every part will be known as 1 centimeter. Okay, now they said 1 centimeter, okay, this much, but I have to go more shorter things, like some ant I have to measure. Ant height is, ant length is how much. So he said, okay, 1 centimeter is there, divide in 10 equal parts, and every single part will be known as 1 millimeter. Then they said, okay, now I'm measuring some bacteria. Okay, something else, cell, inside going that, atom, something like that. Then you said angstroms, then it's about 10. Okay, and it's about minus 10. Like that you went, picometer. Okay, so you are dividing, like that you are going. Okay, in feet also, 1 feet is there. Okay, in that if you are going very little bit small, then 1 inch. In 12 inches, 1 feet comes, right? Like that you can measure. So unit conversion, okay, from one set of units to going another, meter to feet, very rarely required, because we deal in SI unit. Okay, now if I have to go a little bit big side, let's say meter is given, something is very big, you will say 300 meter, 345 meter. Why? Give me some bigger, right? 5000 meter he is saying, right? Instead of that, we will go in bigger, let me say kilometer. Okay, that way it is the unit conversion happens. Okay, so this is the thing. Okay, now next is what you want to note down? No, na? Huh? Note down. Okay, note down this thing. Fundamental quantities. Okay, derived quantities, velocity, acceleration, those all things. Okay, supplementary quantities are important. What is the spelling of quantities also? See, I don't take load on my brain, not even a little bit. Whatever I remember, otherwise it's okay. Supplementary quantities, we say angle. Okay, angle is defined as length, arc length per unit radius. Okay, and steradian we denote with like this form. Okay, what is this? Radius square. Okay, there is no point I will define here. Okay, this is known as this unit is radians. Okay, and this unit is steradians. I don't know spelling of steradians, but I every time write down SR. Okay, understood? Radians, you know. Steradians, something new is there? Right, something funny is there? No, na? What? Spelling, why would I know the spelling? Go to hell. I know what is the answer will come. That's it. English no one is asking me. Fundamental quantities. Okay. Done? Derived quantities are those only: velocity, acceleration, force, magnetic field. Magnetic field we know, that kind of quantity. Those are all are derived from this current and these combination only you make, and you will get that thing. Okay. So next is unit conversion. Okay. There is SI unit and CGS unit, right? So SI unit and there is CGS. Okay, so in SI unit if we measure length in meter and this in this centimeter, time in seconds, and here also seconds, and what else remaining? Mass here in kg and here in gram. Rest all quantities and same. Okay, these two are only different, rest all is same. Okay. Next is your basically finding the derived quantities. Okay, units of derived quantities. In that what we say is that if let's say if you have to answer the velocity, or let's say first speed. Okay, you don't know what is the unit of speed. Okay, but you can simplify it using some formulas. Okay, and bring it towards the fundamental quantities. Okay, like speed you can say use any formula, distance upon time, right? Distance is what? Meter, and time is what? Seconds. So we can say this is meter per second. Okay, similarly this is velocity. Velocity, what you can say? Displacement upon time. Displacement is also in meter and time is in seconds. Next, what? Acceleration. Now when I went to acceleration, I know the formula velocity per unit time. Okay, but the problem is let's say you derive from this, you bring weight. Okay, I will, if you need time for writing down, I will give time. Okay, In between, no one will know. Velocity per unit time. Like let's say these things unit you need, right? You use a formula to simplify it, but still there are some quantities whose formula you don't know, whose dimension you don't know, or whose unit you don't know, right? Then what you do is that particular quantity you more simplify, right? So velocity is what? Displacement per unit time. Time per unit time, right? So this is what now distance is meter, time is second. So meter per second square. Got it? Simplify the formula. If there are quantities which are to be simplified ahead, you simplify it also. Okay? Like let's say we take a big example, force. Okay? Force I can use mass into acceleration. Now mass I know kg, but acceleration I don't know, right? So acceleration I will simplify velocity per unit time. Then in that also I got mass into velocity per unit time. Still I don't know velocity, so I will simplify velocity also. What is that? Displacement per unit time. So like that I can simplify, and I can bring everything in basic units. Okay? So what is this? Kg meter per second square. Okay? That can also be called as Newton. Okay? You write down both, answer will come same. Okay? Both meaning is same only. This is SI unit, this is also SI unit. Okay?